Hello, AP Calc. So, my last video for this week, and possibly my shortest, don't know yet, we'll see how long it takes me to get through it, but I think it might end up being the shortest, is part 2 of the definite integrals, or definite integrals. And that is how to use your graphing calculator to calculate this. So we're going to calculate the definite integral using your calculator to find an exact value. But we will have to do this in the future by hand. But I'm showing you how to do it on your calculator this time. So for now, I'm going to. I think I might mute my picture here because that's not the right one. That was my screen. Oh, here. This is the one. I just muted myself. Okay. Because I want you to see my calculator here in my window. My little window was up. So let's clear this out. Quit out of this. What you want to do to find the definite integral on your calculators is you're going to go into, and again, this is a little different depending on the version of the calculator you have. So if you have a very old calculator, you might not get this nice integral symbol here, the limit symbol. You might have something else. And if you have that and you have a problem, let me know. I think how it works is you need to put in the function. So you'll just get this fn int, and you'll have to put 4 things in with commas separating them. The function, comma, x, comma, lower limit, comma, upper limit. I think that's what it is. Let me back out here. Let's start from the home screen here. How you get how you use your calculator to calculate an integral is under math. So here's the math button if you can see my mouse cursor. Click on that. And number 9, way down here, number 9 is fn int. It's actually under, it's right under n deriv. That's what we used earlier in this year. I'm going to hit enter, and it's going to bring up this integral. So now this is what I was saying. If you have an older one, it'll just say fn int and have parens, and you need to enter 4 things. Here are the 4 things you need to enter, but you got to make sure you get them in the right order. So when you have the other one. So what we want to do here is let's find the limit of the function 2x squared from 1 to 3. So the first thing that you want to enter is the lower limit, or that's where the cursor puts it on. Apparently I shouldn't hit enter yet. Sorry, let me quit out of this. Let's try that again. Second. So let me clear this. Go math. Number 9. I can just hit 9 for the shortcut. 1. I'm going to put 1 in. Don't hit enter until you're ready to calculate the whole thing. I'm going to hit the up on the D-pad to go up to the upper limit and do 3. Okay, I'm going to hit right to go over to where the function is. I'm going to put 2x squared in. Hit right again. I need to put the variable that we're deriving with respect to. So that's going to be x. Okay. I'm going to hit enter, and I get 17. So that's what it should look like. And it gets 17.3 repeating. Okay. Another thing you could do, depending on what's going on, is if you have the function in the y value already because you graphed it or something. So let's say that's in there, and I don't need to graph it to do this. And I quit out here. I can do math 9, do 1, up, 3. Under vars, I don't know if I've showed you this before, but under vars is a very useful tool. Vars, go to the right one, yvars, under function, first one there, you have y1, y2. Whatever is in your y1, if you select this, this will treat that like that function, whatever's in there. So then I can make this x still. So, and if I hit enter, you'll get the same thing because this is pulling whatever's in y1. And that might be useful. A useful shortcut in the future. So let's do one here. We're going to integrate the function x over x squared plus 4 from 0 to 5 using our calculator. I'll just put it all in here. I won't use the y1 because I don't have anything else I'm going to do with this function. Actually, you know what? I changed my mind. I am going to put it in here. So I want to do x. You got to be careful here. Well, first of all, don't put 1 in. I don't know why I clicked that. I got to be careful here. X divided by, I want to make sure I do x squared plus 1 all in the denominator, so I need to put that in parentheses, or the plus 4 will be outside the fraction completely because of order operations. Actually, let me look at this graph real quick. So we're integrating from 0 to 5. You don't have to do all this here that I'm doing now. I'm just curious what this looks like. It looks like it's always positive, but let me do -3 to 3. From what I saw, it didn't go up very high. Okay, so it is very, very slim. I could even go from -1 to 1. Why this might be helpful is you can kind of get an idea for what this area might be from the size. The rectangle here, this window right here, would be, this goes 5s, okay? So this is definitely going to be less than 5. It's probably going to be less than 2.5, because 2.5 would be a rectangle that goes about here. So you can kind of get an estimation if you're to make sure you're doing it right by looking at that. But that wasn't required of what we're about to do. All they want us to do is use this function, 0, put 0 in there, put 5 in there, enter the function, which rather than entering it again, I'm going to go in here and use the Y1 and then hit X. And I'm going to guess something less than 2, maybe 1 something. Oh, less than 1, just under 1, just under 1. Okay. And which makes sense from what we looked at in the graph here. I mean, I'm not surprised by that, because 2.5 would have been like here. So that makes me feel comfortable about the answer, that I could kind of guess an approximation that was close to it. So, yeah, that's it. Just 4 problems. Not too bad. Pretty short video. Thank you, and have a good day.